billion.
So where is all that investment going that Intel's making? Because we just got $8.5 billion from
We did. We got 8.5, and that kind of goes with the 100 billion we're spending just in the U.S. and another around 50 billion in Europe. So we're working as fast as we can to build out the diverse supply chain focused on Western world.
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. This is Darren Pulsipher, Chief Solution Architect, author, and most importantly, your host. On today's episode, Government Digital Transformation with returning guest Greg Clifton and new guest Jason Dunn-Potter.
Greg, Jason, welcome to the show.
Thanks for having us, Darren. Appreciate it. Glad to be here at the HPE CTO Summit.
Yeah, this is going to be a really interesting episode. I'm excited about this. Jason, this is your first time on the show. Greg, you've been on the show. This is your fourth time?
Maybe.
Yeah,
you were desperate for.
I was desperate. Greg, you were second. You were my second guest on the show.
That's right.
If I remember right. Yeah, the first external guest. I did the first episode, and you did the second episode. So it's good to have you back again, Jason. None of my audience knows anything about you, so can you give a little background on you?
Sure. So Jason Dunn-Potter, Solutions Architect under the DoD team. You might have seen me at a SLED event. You might have seen me at a Fed event. I spent 26 years in the Army. My last job was a White House comms agency CTO, opposite Bill Burnham a decade later. And then I got to tell you, it was a magical ride at Intel. We've done a lot in the last 2 years, and we're very excited about some of the stuff we're doing now. Thanks, Darren.
Great. Well, Jason, we're glad to have you on the team, obviously. Today, we're going to talk a little bit about Intel's position on digital transformation. The name of the show is Embracing Digital Transformation, so obviously Intel has a good part in what that means. But Clifton, give us a little bit of a background on our journey, Intel's journey into digital transformation.
Sure. Yeah, well, obviously we've been at the foundation of compute technology, right? We sort of helped found Silicon Valley and the computing capability, but throughout the years, we've seen lots of different transformations, right? It was mainframe to client server. Sometimes I say cloud is kind of like a mainframe, and now everybody wants to go to the edge again, right? And we're transforming again. AI certainly transformative, but we're now transforming in how we make the compute, right? Everyone's heard of the CHIPS Act, and they've seen the investment the U.S. is making in our semiconductor manufacturing capability here domestically. That's a major change, and actually it's a great thing, right? We saw even this past week with an earthquake in Taiwan. Luckily, nothing happened to the infrastructure, but what if it had, right? We're so dependent on this compute environment to run our digital lives, businesses, and government that we've got to have that diverse ecosystem for security, for innovation, to run all this compute infrastructure. So that's a big part of what we're investing in.
So where is all that investment going that Intel's making? Because we just got $8.5 billion from.
We did. We got 8.5, and that kind of goes with the 100 billion we're spending just in the U.S. and another around 50 billion in Europe. So we're working as fast as we can to build out the diverse supply chain focused on Western world. So we're building in Germany, Poland, Ireland, Israel, and then here in the U.S. in multiple sites in Arizona, California, Oregon, New Mexico, and Ohio. Right. So to me, it's one of those must-dos, not only to deliver the compute capability, but to bring the innovation of advanced manufacturing back to the U.S. Right. How do you solve problems in manufacturing translate to how do you build new technology? The other side of this is the workforce. Folks that actually can make stuff in these factories, but the other side of that is actually building these factories is a marvel, right? And having that technology to build these things in the U.S., not only to operate the factories, but build it, to me, that's a national treasure as well, and something we've got to be doing.
Yeah, go ahead, Jason.
But Greg, I was going to say a couple key things that you must know. First off, if anyone wants to go halvesies on a Dairy Queen in Ohio, this is the time. All right,
Jiffy Lube,
pick your favorite thing. It's going to be Culver's, just so we're clear. The other thing to think about is that Intel's making a major investment in colleges and universities. We need a workforce. So if you got folks that need to get into STEM and engineering, this is the time. Ladies, I'm looking at you. Please help me spread the message. Last year, Intel offered full ride scholarships to Ohio universities to get engineering degrees, full free ride. We can't make it better than free. Please apply. Please tell your friends to apply. We're looking for workers in those spaces. There's a huge gap. We were out at Lyceum last week with a lot of leadership, and they identified a huge gap in capability.
Now let's talk a little bit about the Ohio fabs.
Absolutely.
We're building 2 fabs right now in Ohio.
Yep.
And there are 18A fabs, correct?
That's right.
Correct.
So 18A is angstrom. So 18 angstroms. Anyone have any idea how small that really is? I mean, you do. So here's an example, and this blows people's minds, right? 18 angstroms is about 1.8 nanometers. The coronavirus, 72 nanometers in diameter. So we are producing transistors at 1.8 nanometers.
Right. So why do you care, though? That's the point to understand, is that we're moving the needle down, which is bringing more performance, lower swap, better performance all the way across. It's the era of angstrom. If you're not familiar with what we're talking about, it's going to affect you directly, whether you know it or not. But the other thing to understand beside the science of it is that it's evolution. We are literally moving forward in technology integration. We've got a lot of R&D going on. I know I posted about it yesterday with Ferberos and EMIB, but also some of the stuff we're doing with PowerVia and how that all ties together. And that's what I think. I think the thing when you talk about those, make sure they understand it's not a fab, it's a foundry, right? And the key delineator there, right?
Probably heard in the news, Intel's actually separated out our businesses. So we have a foundry business and a product business so that both can be as efficient as possible and deliver leading technology in a cost-efficient, cost-effective, leading technology manner. And the other part of that is, how do you solve your problems? You know, we saw today some of what it's going to take to deliver AI. The world of just building on the best CPUs or GPUs may not be the best, right? Just trying to out-architect your competitor, whether that be in government or in business. So what our business model allows is that, yes, you can take our commercial off-the-shelf products. We've got CPUs, right? Our Xeons and our cores and client and server have been an institution in this space. We have GPUs. We have high-end HPC and training, as well as very energy-efficient edge GPUs as well. We've got AI, really generative AI, large language model, custom AIs, our Gaudi product line that HP is bringing to market later this year. We've got infrastructure processing unit, FPGA. So we have a breadth of commercial products. But if that doesn't meet your need, you've got a design, you bring it to us, we'll make it. Or you've got a die, you need us to package it, we'll do that final packaging, you go give it to HPE, they'll put it in a server. If none of that works, we will actually design and build it from scratch for you. Right? We will do all the design, post-silicon validation, packaging, same thing. Hand it to our friends at HPE, they'll put it into a server. And as you said, Jason, if none of that works, we'll turn on our R&D engine, invent technology, and build that for you.
Yeah, it's a really exciting time, Darren, especially when you start thinking about, like Greg said, I don't care if you sketch it on a napkin or if you have an idea or you're already 3/4 of the way. The other thing is ingesting our IP, right? Taking our IP, wrapping it with what you're building, making a better you, and then also having that foundry separated physically, emotionally, and financially from the company, so that you can do firewalled off operations, right? They're going to be
a great example of that is we recently signed a huge agreement with ARM.
Yes.
In the past, ARM and Intel competed, right? Because we were selling CPUs.
Did anybody see that coming? I've got to ask. Did anybody expect to see an ARM leadership person shaking hands with an Intel foundry director on stage in front of everyone? It's a game changer for some of you. If you do not understand risk and some of the things that will involve, it's a huge change of business.
Right. So I understand all the silicon stuff, right? That's where we make all of our money and things like that. But our customers don't care about silicon.
No, never have.
How many of you guys out there in the audience today, how many of your customers ask you, what process node that chip was put on? No one? No one really cares. So how is Intel addressing the problem of actually solving mission capabilities, solving problems?
So we've done a couple things. First thing is Articulate. If you guys don't know, we launched a lifeboat with our actual software company called Articulate. It's an AI integration company that custom builds artificial intelligence solutions because it's hard. AI is hard. And I want to talk about this for a second. This is something I want to make sure you guys go back to your customer with. When I talked about AI, it's like talking about, hey, I need to buy a computer because I need a computer, right? I heard about computers. I want to buy computers. We should get computers. Darren, in 1984, we should get computers for the office, all right? How about we change the dynamic and actually get after the actual problem? Is it a toy, i.e. we're exploring, we're going to assess AI and see what we want to do? Is it a tool, like we know what we want to solve and we're going to use it to leverage? Or are we going to bring a teammate, i.e. I'm going to offload some of the things I'm already doing and move it over because I know enough about AI to get there and that could provide me direct services and take advantage of things that I don't need to do on a daily task. I got to tell you, the daily updates or the weekly update grade that I'm late every week on, it'd be really nice if we just took my outbox, figured out what was important based on the volume of emails I sent and helped me formulate that outbox. I'm looking forward to that, like tomorrow, so we can stop being late on the weekends.
I actually have an AI PC right here in front of me.
No, you do, right? You showed that to me this morning, so it's real.
Yeah.
Anybody from Microsoft in the room? Yes, sir. Microsoft Copilot. Are you kidding me? Yes. If you do not know what we're talking about, this is where AI PC is going. Right? That is one of the thousands of tools that are coming to you right now. You can download it now on your home box. By the way, I tried. It's good, but it's better on that. Yeah.
So, all right, you talked about software, but let's talk about like real problems that people are having in Department of Defense, for example, or Department of Homeland Security, or civil. How is Intel engaging with them on that? Because we still talk to those in customers, and they don't really care about silicon.
They do not. So one thing we've done is we've actually gone out to the field. So that's the other thing. Everybody knows Intel's in the field now. You see us at all the events. Anybody not seen an Intel rep in the field outside of this forum? Every forum you go to, you will see an Intel rep somewhere walking the floor. If you haven't seen them, find them or send us a note. We'll tell you who it is. Because we are going to go to every trade show. We're going to go talk to every senior leadership position we can. And we have done all of that. I got to tell you.
Why, if people don't care about silicon?
They don't, but they care about solving their problems, right? And that's where we gather that information. So we have a couple routes to market for you guys. First is we're taking that information back to Intel Labs, 2,000 laboratories and all the engineering work. We meet with them on a regular basis now to give them voice of the customer. What's broke that we can't fix? The other thing we're doing is, some of you know, I have literally gone to you and say, hey, you need to partner with somebody because they bring a solution that augments your solution and I'll package based on government feedback. Here's the other thing to think about. Ladies and gentlemen, we're 1 degree back from the government. So I don't have to fight the RFP issue. They can tell me things they can't tell you directly because we're not in the direct food chain. So we have the ugly conversations with whiteboards about what's in the realm of possible. So we can serve as custom advisors. We do thought leadership to them, what's in the realm of possible, which helps position you, especially when you have solutions. I know we're working on a bunch of efforts at headquarters to like funnel all of the folks to say, hey, I want to do zero trust. Great, there's like 64 parts of that. Great. How do I map to which part are you solving? Who's our partners in that space and what can they provide? Just like we did with GDC.
You alluded to something that I think is really important for us to touch on.
Sure.
Our ecosystem is incredible.
Absolutely.
Right. And it's you guys that are in the room with us today. You are our ecosystem partners at Intel. And you are vital to getting the word out on leveraging silicon to get solutions to your end customers. So it's vital that you work with Intel account execs, the field reps that are out there, because we are showing the future to your accounts, to your customers.
You talked earlier about machine learning, AI. Well, what's the question? What's the answer I'm trying to get to? So even though you don't really care about the silicon necessarily, it's a key ingredient to make it happen. So I think the ask is, let's continue partnering. Let's continue asking our customers what their challenge is. And then how do we solve that, right? And that's where you kind of look at the broad set of hardware, software, that you put into play to solve those problems.
I mean, I'm on like 20 or 30 training calls a week. So if anybody's not taking those, we do those to every partner ecosystem. I don't care the size of your company. If you want to know about something we're building or something we're doing. Also, we've given classes on what is the Air Force to some of the new account reps. Anybody been new to an account, trying to figure out what's in the account? We understand the mission set. So we're here to enable all of that. Right. And
so that's something interesting you brought. You said the software, the hardware. I saw the 3 pillars that Sam brought up earlier. We have 6, Sam, so sorry. But you mentioned all 6 of them in your presentation. We talked about edge. We talked about AI. We call it ubiquitous computing, which is really hybrid cloud. Security, which you had on the bottom. Advanced communications. And the last one, which is my favorite, is data management, right? Which you brought up earlier. Data is gold, right? It's the oil. We're in the oil. We're in the oil world here, right? It's the oil of this century, and we're not managing it very well. And one of the problems that I have seen is a lot of times when we go and engage with our customers, we're creating not only data silos, we're creating technology silos. And I'm seeing the exact same thing happen today with AI. People are I'm buying an AI cluster. Well, that's a mistake. Because when AI moves off of GPUs onto NPUs, what are you going to do with that GPU cluster you just had? And what was mentioned earlier today was the GPU, we can't generate enough GPUs to keep up with the demand. But new technologies are coming into play, like the memristor or neuromorphic processing units and things like that. So putting yourself into a box like that is very dangerous. So what we're proposing and what we're really trying to push forward really hard right now is to go back and look at enterprise architectures. How do I establish an enterprise architecture so I can consume new technology quickly? I can manage my data across all these technology silos, and I can break down the data silos that are already existing. So we've got an architecture.
It's hard though, right? So that's where we're here to help, right? It's hard. There's a lot of change. I mean, I'll be honest. I'm going to apologize to the OEMs in the room. We're moving at a rapid pace, like 5 nodes, 4 years, and more now, right? How do you keep up with that? How do you know what the customer needs based on what we can now offer? We couldn't offer 20 minutes ago. If you don't understand with Xeon and some of the acceleration we've done with that, we're taking on some AI workloads without a GPU, which was amazing. But then also we're doing things like with Netflix where you're like, hey, I can do transcoding faster, better, cleaner. And so now it's a 3x return on investment. If you haven't seen that, go on to YouTube, hit Intel Space Netflix. It's an amazing story. They took some of our GPUs, they mapped out their transcoding solution so you can go from tablet to form to TV on the house. And then they turned around and used the exact same architecture to accelerate their AI algorithm that determines what are you watching, right? How do I deterministically figure out based on the last 20 things you watched, how do I figure out what to recommend to you? So the content delivery notes, CDNs at the local level. Folks, this is where we come in super handy. We can show you some of those scenarios and use cases where you can figure it out, and you can go back to your customer and say, look, we've already solved this. It is solvable. And we have a prime solution that's baked in and built in.
Okay, so what I'm kind of hearing a little bit is the days of a hammer and nail are gone.
Yes.
Right?
The days of
you can't just throw cores at problems, is what I'm hearing. Right? So we have the world of heterogeneous compute moving in. Right? Where I have specialized compute for different types of workloads, whether it be AI or inference. And there's a big difference between AI inference and AI training.
Oh, sure. Doctor versus doctor in school versus doctor in the field. Oh, by the way, hey, Doc, thanks for coming. Okay, we'll work that out. Darren, you couldn't be more right, but the other thing is we gave some tools to the field. So if anybody's not familiar with our Intel Developer Cloud, last year, Greg Lavender, the CTO of Intel, announced, hey, we've got this Developer Cloud. You know your kids in high school can try that out for like 30, 60 days for free. Put some stuff in there, test out workloads if they're in the software space. Guys, stop buying giant non-production test systems. We're here to help you. We actually have built that for you. So you can go in and do a workload benchmark. So when you go to your customer, you say, hey, if you're a software ISV or whatever, I ran this is the results, and this is what it actually looked like in the real, running on Gaudi, running on Xeon, right, or whatever the
or whatever accelerators are.
Or whatever accelerators.
And we are in the midst of trying to get that FedRAMP certified. A lot of it's testing, so you don't necessarily need it. You know, you're not putting classified data or anything else on it. It's just test data. But for those that can't use the cloud at all, we are even looking at an on-prem version. Talk with HPE, try to give somebody that capability so they can take it in their environment, in their lab, to do that testing. So before you deploy into production, you've really looked at the compute options to maximize your data flow.
So you mentioned free. I really like that topic. We're very excited about some of the most associated stuff that's going on across the DoD. We're huge fans of agnostic compute, so you can migrate from A to B. This is where we get the multi-hybrid cloud. I know you talked about that earlier with GWCC and some of that GreenLake's integration, right? The other thing I was really excited about was SYCL. SYCL, how we do the conversion for GPU.
On the one API.
On the one API, sorry. So if anybody's not familiar, SYCL is the acronym. It's a software set that allows you to run GPU software applications. Intel does not have a licensing model for that. And I tried to explain to somebody, they're freaking out about it. Like, well, it's not real. It must be freeware. It has no value. I was like, guys, when you buy an Intel GPU, it's just like when you buy an Intel CPU. You get the software because you bought the hardware. We just tack it in there. SYCL is by design, same. And by the way, I'm not going to tell you, but if you run it through the benchmark workloads, you'll be surprised. It runs on everything, not just Intel GPU.
Yeah, there's something really actually cool about one API and SYCL. I can target it for CPUs, GPUs, NPUs, FPGAs, and even custom ASICs. So what that means is if you're a software developer and you're developing algorithms, I don't target it to a specific piece of hardware. I write the generic algorithm, and the one API compiler optimizes it for the different hardware that you want to target it to.
Yeah, I will tell you
Pretty incredible. It decreases.
Yeah, right.
Well, it was a game changer for Argonne, right? When Argonne National Labs made the transition, we're working on Project Aurora with HPE, and we're really excited about all that. They were super excited the fact that they don't have to recode everything to slide over to the software, right? It just slides over, hardware to hardware exchange.
So, as you guys can see, there's lots of really cool technologies all involved in this digital transformation that Intel is really enabling. And I've said this a couple of times. It might sound a little bit hubris, but it's true. We don't predict the future. We create it. Because the chips that our labs are working on now, they're going to be available in 5 to 7 years. And you guys haven't seen anything yet until you see some of that stuff. It's pretty, yeah.
I think I talked about it in terms of what we're doing here in the U.S., but we're also looking at doing some enhanced security capability as well. So not a whole lot we can talk about in a public forum on that, but we are certainly working very closely with our government partners, understanding what they need, what they want, so that we can deliver an end-to-end secure capability. And then obviously we'll give it to you all, take it to Chippewa Falls, and finish that complete packaging and put it into a system.
Well, and even the traceability aspect of that is critical, and that's actually built into our chips today.
Well, the other part of that too is the confidential computing. If you want to talk about that real quick, once you actually get the device and start using it.
Yeah, this is an interesting aspect, confidential computing. How many of you are aware of the term confidential computing? A handful. All right. Yeah, I'll explain it real quick. So confidential computing basically takes the whole idea of encryption into memory. So right now, first off, if you're not encrypting your data at rest, I mean, I can't believe you wouldn't be. And people say, oh, I take a hit in performance. You don't anymore because all of that encryption is happening in ASICs now. Same thing with data in transport. But there's a vulnerability with data in memory, right? If I'm running on a box and someone has access to that box, they can dump the memory and get access to all my data, including, top secret algorithms and things like this. So Department of Defense is very concerned about this. They wanted to be able to run their algorithms in encrypted memory. They were looking at homomorphic encryption. Very slow.
So I'll break this down a little bit because a lot of people get confused. This is not about, you're not worried about your cloud provider being vulnerable. It's more about worried about your cloud provider being just as vulnerable as you are with all the things that you got going on, right?
Yeah, that's true.
And it makes it more complicated than that. But I try to explain it really simply. It's like having a community refrigerator in your house where you go in, all the food is, your food's in the thing. You like your tub with your lunch. However, at the end of the day, everybody shares the same tools in the kitchen, right? You pull out your food, you make your sandwich, you clean your tools, you put them away, and you put your lunch back in the thing. This keeps everyone else out of my food chain, right, process. But we all share the same kitchen, right? This is really important, especially
But you don't share the same memory.
You don't share the same memory, right, exactly. So that's the whole point of the structure, is that you cut off pieces of that. When we talk about this, we really apply to things like financial records, HR, medical field, right? Anywhere you have to have PII, PHI, right? This is critical for cloud architecture. We're really sad we haven't gotten there already. I will tell you, when Sharon Woods looked at it last year at our Intel Public Sector Summit, she came right in and said, I need more. I need to know everything. I don't know why we didn't do this before. We didn't ask the right questions because we didn't know. We didn't know you could even do this, right? So now everybody's in. The other thing you're protecting against is junior admins. We all understand that sometimes you get those new admins in there and they're just surfing around the government data. That is not going to end well. All right. This takes advantage. This specifically negates all of that.
So the key here is that this is available in all the cloud service providers have it. It's also available already on any of your HPE servers.
Yeah.
It's already there. All you have to do is turn it on. So yeah, one of the coolest use cases I can think of is one that we did with the FDA on clinical trials. One of the biggest problems with clinical trials is you have to protect patient information. And you also have to protect the algorithms that researchers are using to identify new drug interactions and cures and things like that. So what we've done is we've set up these secure enclaves in clinical sites, not exposing their patient data to the researchers, and the researchers can drop their algorithms directly into these secure enclaves, so no one can see what's inside the lockbox except the results coming out the other end, which have been completely sanitized. Really cool case, and it's actually helping quite a bit on drug discovery.
Yeah, and I will say we can't get into classification level stuff, but there are several government agencies that are looking at this for other reasons, right? Think about classified operations where you need to silo off people and information. This allows you to do a lot more flexibility, especially globally, using all kinds of solutions.
Thank you to Jason and Greg for coming on the show, and a special call out and thanks to HPE for letting us record at their latest government CTO summit. Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.